Okay, well, today I'm going to shift gears a little bit. I know we had talked yesterday about doing more with the applications of vectors, but I think what I want to do is I want to shift and get to the oblique triangles just so we don't run out of time. And we really only have 2 lectures left. Thursday, we'll take a quiz, and that'll probably be about all the time we have. So I do have a quiz I am going to give you to take today. So you can take that quiz with you. And we are going to jump to oblique triangles. Since Andrew's not here, we'll pick on him today. Oblique triangles, which we'll nickname Andrew triangles, are triangles with no right angle, so they're just not right. So I'll let you guys share that with him, or you can see it in the recording. Sure. So we're looking at a triangle, something like this, with no right angles in it. Now, all triangles have 6 parts. We have 3 sides and 3 angles. We need at least 3 of those pieces to be able to find the other pieces. The key is, of those 3 pieces, at least one has to be a side. And we did this with our right triangles. We had the right angle itself, and then we either had to have 2 sides or a side and one of the other angles. Well, in oblique triangles, there's no right angle, so we have to know 3 pieces without a right angle in there. If I label my triangle, angles A, B, and C, the sides get labeled by the angle they're across from. So this is side A, side B, and side C. Notice the sides are little small letters, the angles are capital letters. The reason those are linked like that is if this angle gets bigger, this is the side that would get bigger or smaller if everything else stayed the same. So that's the side that's related to the size of that angle. Because the size of the side, the length of the side is related to the size of the angle, we come up with a relationship called the law of sines. What the law of sines says is that the length of the side divided by the sine of its opposite angle, so the length of side A divided by the sine of side or angle A, is a constant for that triangle. So the length of side B divided by the sine of angle B is going to be the same as that. And it's also going to be the same as the length of side C divided by the sine of angle C. So now with this in place, as we said, we need 3 pieces. At least one must be a side. So let's start out with the case where we are given one side and 2 angles. And we're going to actually look at a couple of examples of this, a couple of cases of this. Yeah. Sure. There. You bet. So now again, we're going to look at where we have one side given and 2 angles. So I'm going to be given here that I have 41 and 80 degree angles and a side of 18. I can label this however I want to. So I'm just going to go angles ABC, side ABC. When I'm dealing with law of sines, I need a side and its opposite angle that I know the size of, that I know the number for. Here I have that. I have this side, and this is its opposite angle. So that's what I'm going to use for solving the rest of this triangle. I have the 18 feet over the sine of 41 degrees. Now there's only one other piece of information I have here, and that's the 80-degree angle. Well, the angles go on bottom, so that's going to be the sine of 80 degrees on bottom. What side's going to go on top of it? Side C, right there. That's the one that's across from it. So now we will cross multiply and divide. It's going to be 18 times the sine of 80 divided by the sine of 41. These are degrees, yes. Now you do 18 times sine of 80. Make sure you close your parentheses, then divided by the sine of 41. 27.02. Perfect. Yep. So we got that 27.02 feet there. Now looking at this, our next step is actually kind of a step backwards to stuff we've known for quite a while. That's going to be finding this third angle. How do I find that third angle? Well, the whole triangle is 180. We subtract the 80 degrees there and the 41 here. We get 59 degrees. So really, if we're given two angles, we're really given three angles. Because the third angle is just subtraction. So now to find side A, well, I'm going to go back to my given. I have my 18 feet and its opposite angle of 41 degrees, so 18 over the sine of 41 equals, I'm trying to find side A now, so I'm going to put that on top. What has to go below it? Sine of 59 degrees is its opposite angle. So we will cross multiply and divide. So 18 times sine of 59. Again, make sure you close those parentheses. Divided by sine of 41. 23.52 will round it to. Very good. This is not a right triangle, so no, you could not. Now, before we're done here, maybe not today, but most likely tomorrow, we'll look at something called the generalized Pythagorean theorem that you can apply to non-right triangles. It's actually called the law of cosines. So there's a case where we had two angles and a side, and we were able to find everything else. Now the other case that we might have, still two angles and a side, might look something like this. Let's say I'm given that this angle here is 82 degrees. This angle down here I'm going to be given as 51 degrees. And I'm going to give this side right here as 20 inches. Now again, I can label them however I want to. Looking at this, I need a side and its opposite angle. Do I have that here? No, I don't. But can I make it happen? Yeah, because this angle here is just going to be 47. Yes, 47 degrees. We're subtracting from 180. 180 degrees minus the 82 minus the 51. Is that 47 degrees. So now that we have that angle, then we do have a side and its opposite angle. So it's 20 inches with a sine of 47 degrees. Which one do we want? Which angle do we want? Which side do we want to find first? A or C? C, okay. What angle is going to go across from that then? 82 degrees. So then we will cross multiply and divide. 20 times the sine of of 82, make sure you close the parentheses again, divided by sine of 47. 2708, you are correct. So that was C. Let's find A. We're going to go back to that same starting point. So 20 inches over the sine of 47 degrees equals A over the sine of 51. Perfect. Let's cross multiply and divide. 20 times the sine of 51 divided by sine. 2125. You are correct. Now, I didn't do it on the last one, but I'm going to do it here. I should have done it on the last one. Let's double check and make sure these answers make sense. Remember, one basic rule of triangles is the largest side is opposite the largest angle. Well, this is the largest side. 82 is the largest angle, so that's true. And the smallest side is opposite the smallest angle, and that holds up here as well. So that's one way to double check to make sure you didn't make a really silly mistake. Doesn't catch every mistake, but it's a start. So the next case we're going to look at is we're given two sides and one angle. I'll make a distinction here. The side opposite the angle is the larger side. It's going to be very important in a couple minutes. The side opposite the angle should be larger. There will be a case where the side opposite the angle is smaller, and then there's going to be something else we need to know. So let's say this angle here is 39 degrees. This side over here is 45 feet, and this is 42 feet. Not necessarily drawn to scale, of course. So let's label A, B, C, little a, little b, little c. We do have a side in its opposite angle, the 45 across from the 39. So 45 over the sine of 39 degrees equals, I have the 42 as my only other piece of information. It's a side, so we put it on top. What's it go over? Sine of B. Now we are looking for an angle here. When we're using the law of sines to find an angle, what we're going to find is the sine of that angle. So we're going to cross multiply and divide here. Sine of 39, make sure you close the parentheses again, times 42, divide by 45. Gives us 0.5874. That is the sine of angle B. So how do we find B? B is the inverse sine of 0.5874. Now I just keep it in my calculator. I'll do second sine and then second answer. 35.97 degrees. So that's angle B here. Now that makes sense. This angle should be a little smaller than that one because this side's a little smaller than that one. Now to find this side up here, I just have to subtract. 180 minus 39 is 141. Minus 35.97 is 105.03 degrees. Correct? Okay. Now we can find side C. Just as easy as can be. Same constant. The same starting point, 45 feet over the sine of 39 degrees equals side C for the sine of 105.03 degrees. So 45 times the sine, 105.03, close those parentheses, divided by the sine of 39. 69.06. Says feet. And that makes sense that that angle is a lot larger than the other two, so that side is a lot larger than the other two. Our next case, we're going to be given two sides and one angle. The side opposite the angle is the shorter side. What do I mean by that? Well, I'm going to give you the information here in a little bit different manner than what we have been. Rather than drawing a picture, I am just going to state angle A is 31 degrees. Angles B and C we have to find. Side A is 27 inches. Side B is 59 inches, and side C we have to find. Based on what I have here, let's try to draw a picture of what this should look like. Here's my 31 degrees for angle A. We're going to put angle B here. Oops, sorry, let's put angle B down here. Angle B is going to go down here. So this will be angle C. This will be side A over here is 27. This is side B is 59. So this is going to be side little c down here. So we need to find those two angles and that side. The problem is can I guarantee that that's the picture? No, because I don't know anything about the size of side C or angle C. There's a second possibility here. It could be tucked in like that, couldn't it? So in this case, where the side opposite the angle is shorter than the other side given, we need to know if this angle here that's opposite the other side is obtuse or acute. Now in the example I'm giving you here, it doesn't matter. Let me show you why. If I do 27 over the sine of 31 equals 59 over the sine of B. We're looking for an angle. We're going to cross multiply and divide here. Sine of 31 times 59 divided by 27. We get 1.125. What's the problem with that? If we go to do an inverse sine, what's going to happen? The calculator says error. Why? Well, sine can never be larger than 1. Sine and cosine are both between -1 and +1. What that actually means is there's a third possibility here, and that's this. Here's that 31-degree angle. This side is 59 inches. No matter where I let it hang down, 27 inches is too short. It doesn't reach that opposite side no matter where I let it go. So this one does not form a triangle at all. So there are three possibilities when I have two sides and an angle, and that opposite side across from the angle is the shorter of the two sides. There's three possibilities. It might not form a triangle like here. That opposite side is too short. It may form an acute triangle or an obtuse triangle. So now let's look at some possibilities that actually work. I promise I'll make these actually work. So we're still looking at two sides and one angle. I'll give you angles A, B, and C. Angle A here is going to be 33 degrees. Side B is going to be 40 feet, or side A is going to be 40 feet. Side B is going to be 50 feet, and side C we're going to have to find. I'm going to tell you that angle B is acute. So I'm going to fill in the information I have. Angle A is 33 degrees. Side A is 40 feet. Side B is 50 feet. And this is acute, so I drew it acute. So I do have a side in its opposite angle, 40 feet over the sine of 33 degrees, equals 50 feet over the sine of what? B. Cross multiply and divide. Sine of 33 times 50 divided by 40. Let's try that again. Sine 33 times 50 divided by 40. 0.6808. So that tells us then, of course, that B is the inverse sine of that, 0.6808. So second sine, second answer, 42.91 degrees. Now to find C, angle C, we're going to subtract. 180 minus 33 minus 42.91 is going to be what? 104.09, I believe. No, 104. 109. So now I can find my final side. I still got my 40 feet over my sine of 33 degrees equals side C over the sine of 104.09. Let's come up with 33.43. That does not seem right, does it? We'll try that again. Something had to go in here wrong. How did I know that wasn't right? Well, this is the biggest angle. It better be opposite the biggest side. So this side has to be bigger than 40 or 50, right? $71.23 sounds better. That's the biggest angle. That has to be the biggest side. here's the cool part about this. What happens, take that same information, only I tell you that B is obtuse. So here's A, B, C. This is 33 degrees, 40 feet and 50 feet. This is side little c. I'm going to set it up exactly the same way. 40 over the sine of 33 degrees equals 50 over the sine of B. This looks exactly like the way we started before. We'll cross multiply and divide. We get 0.6808. Remember, that's what we had up here is 0.6808. So how on earth do we get a different angle out of that? If you recall, back on our unit circle, a sine of 0.6808 is about like that, right? That's what the sine is. That gives us an angle here. There's another spot that has that same sign right over here. It's an obtuse angle. This angle here is the same as that. So this angle is the supplement. So when I do the inverse sine of 0.6808, I'm still going to get 42.91 degrees. But that's not B. B is really 180 minus 42.91 degrees. So it's 137.91 degrees. It's the supplement. So there we fill that in, and now we can find our final side, or final angle, I should say. We take 180 and we subtract those, and we are going to get what, 9.91, I believe, here for angle C. And now we can find side C. We still have 40 over the sine of 33 degrees equals side C over the sine of 9.91 degrees. That's angle C. We will cross multiply and divide now to get that side. 40 times sine 9.91 divided by sine of 33. 12.64. So you can see the same information given. The only difference is I tell you that B is obtuse here and B is acute here. Gives us very different triangles. This one versus this one. So that's something to watch out for when that opposite side, the side opposite the angle, is shorter than the other side. There's two possibilities. Now, the final possibility when we are given two sides and one angle is the angle is between the two sides. So let's say I give you that this here is a 44-degree angle. This here is 28 feet, 31 feet. That. Actually, I'm going to label it different just so that I'll call this angle C. Just because it fits in with the generic form of this next rule a little bit more. To apply the law of sines, I must have a side in the opposite angle. Do I have that here? Here's my only angle. Do I have its opposite side? No. Can I find any other angles or any other sides so that I have a side and an opposite angle? Not really simply right now, can I? This problem here involves something called the law of cosines. It applies when we have two sides and one angle, and that angle is between the two sides. And this is what I mentioned earlier. You mentioned the Pythagorean theorem. If there's no right angle, you can still apply it. It's called the law of cosines. The length of side C squared is equal to the length of side A squared plus the length of side B squared. That's exactly the Pythagorean theorem so far, but there's an adjustment factor. Minus 2 times the length of side A times the length of side B times the cosine of angle C. So for this particular problem, C squared is, A is going to be 31, so 31 squared, plus B is 28 squared, minus 2 times 31 times 28. Any questions as to where any of those numbers came from? That's just A and B here so far, right? Times the cosine, angle C is 44 degrees. What I'm going to do is when I punch this in my calculator, I'm going to do the square root over that to get rid of the squared there. So I'm going to punch it in like this, second square root, and it's all going to go inside the square root. On your calculators, many of you, when you hit the square root, it gives you an open parentheses. If that's the case, we're going to have to put an extra parentheses at the end for you. So I'm going to do 31 squared plus 28 squared minus 2 times 31 times 28 times the cosine of 44 degrees. Now I have to do one close parenthesis to close the cosine. You guys will have to do a second one to close the square root. Now I get 22.28. This is 22.28 feet. A lot of people start typing this in and they want to hit equals partway through. You cannot. You have to type the whole thing in all at once, or it doesn't work. Did you get to work, Hunter? Try it one more time. Now the nice thing about this is once I have applied the law of cosines once, now I have, come on, change color, a side and its opposite angle. Got to work? Good. So now we're back to the law of sines. 22.28 feet over the sine of 44 degrees equals, now here's the big question. Which side do I want to pick to use? And there is a right answer. Always use the shorter side. Why? Well, for this problem, it's probably not going to make a difference, but I always want to use that shorter side because of what we went through in that last example where that one angle could either be acute or obtuse. This is the longest side on this whole triangle. There is a chance that this angle could be obtuse. So it's safest to use this side. We know this angle's acute. So we'll find that angle, and then this one's just found by subtraction. If I use the 31, when I get the sine of this, I don't know whether it's that angle or it's supplement. Remember? It's the same. The sine gives us two possible angles. This one I know is acute, so I know it has to be just that angle. So this is going to be 28 over the sine of angle B. We will cross multiply and divide. So sine of 44 times 28 divided by 22.28. gives us 0.8730. So that tells us that B is the inverse sine of 0.8730. So second sine, second answer. 60.81 degrees. So that tells us that this one down here has to be 75.19 degrees. So subtract those from 180. And now we're done. Okay, tomorrow we'll take a little bit more time to go over these. For now, homework. I believe this is in your bigger packet that I gave you. Page 387 to 388. 1 through 27, the odds. And page 390 to 391, 1 through 27, the odds. So we'll talk about those a little bit more in class tomorrow. We'll do some more examples. Make sure you've got them down. If we get to that point, we may start the quiz tomorrow before you go. Let you take it and just bring it back on Thursday. Remember, you've got that quiz today to bring back tomorrow. One more quiz, and then we're done.